Second part, we are going to go beyond Hadoop and really talk about various components in the ecosystem. Touch base, what we talked about briefly about Cloudera, but all the different distributions which are available and why they are and what they do. And then we'll talk about various technical terminology and finally bring up Spark, as we talked about, is a face-off between Hadoop and Spark. Hadoop, and for that matter, any data warehousing and other components as well have two parts we're going into in system. One is the storage. You store data in some form or shape, and then you perform processing. For example, if I were to grade people's classroom sessions and the kids' paper, those papers which the kids are writing in the examination is the storage. So that's the data which they have stored on their answer papers, and processing could be the act of correcting those papers, giving them grades and marks, all that. So those are the two components which are going to be part of any single project which you have. And in Hadoop's environment, we have HDFS, which stands for Hadoop Distributed File System. It's the one which started with Google File System and got expanded into Hadoop Distributed File System. It's distributed across the cluster. It's not sitting on a single machine, and that's why it's called distributed. And because it's part of the Hadoop, it's called as HDFS. So that's what is happening right now. On the processing side, Google also wrote in their white paper the MapReduce concept. So MapReduce is a processing algorithm which really helps us to really solve processing problems on this dispersed set of data. And in the next meetup, which we are going to talk and go deep dive into MapReduce and have several stories and examples to really come in a simpler way to explain MapReduce. Particular slide, we will want to talk about the whole ecosystem in Hadoop. And this is a busy slide, a lot going on in this slide, but I think we'll slowly, steadily go through all these components and try to understand what they are doing in the ecosystem. The whole thing started with Hadoop, and that's why it's the foundational, the main layer which we talked about. Box plays an important role in this whole ecosystem or serves a certain purpose. At the bottom, which we'll talk about Hadoop Distributed File System, any data which is brought in Hadoop primarily stored as a file system. Even if it's coming from a database or other sources, it's finally eventually kept in a file system, which could be in the storage mechanisms on all those slave nodes in a cluster. Data, we have that MapReduce engine, the MapReduce version 2 engine, which uses mechanisms to really, has an algorithm to really be able to access this distributed set of data and process across these different nodes. And version 2 is the next version which was brought into MapReduce, and YARN is the name for this resource managing system. YARN stands for Yet Another Resource Negotiator. It's a phrase by itself, Yet Another Resource Negotiator. That was the better resourcing mechanisms which were brought in version 2 of MapReduce, and that's part of the this framework, distributed framework. So these two are the core backbone of Hadoop's ecosystem. This is for the storage piece of it, which we're talking about, and MapReduce provides the processing capability on this data set. Let's go piece by piece on all of these different blocks. As I said, Hadoop, or for that matter, data warehousing systems, are primarily not the creator of data. So if somebody else is the creator of data, we have to have mechanisms to bring that data into Hadoop. And that's where these two vertical boxes come into picture. Scoop. Scoop is a mechanism to get data from a relational system. Our databases, Oracles, MySQLs, and all so on and so forth. Primarily, a lot of the data previously was processed through these systems. When Hadoop and this kind of systems came into existence, there was a need to be able to bring that data from relational systems into Hadoop's distributed file system. So Scoop provides that mechanism. Scoop stands for combination of two words, SQL plus Hadoop. It's a combination of that two words slapped together, and that's how Scoop is created. It's a two-way bridge to get data from relational databases into HDFS and also to export. So it serves the purpose of back and forth. In certain scenarios, we need to send data out of Hadoop into relational world as well. But the fun of Hadoop and this big data systems primarily does not come from structured data. It comes from the unstructured data. So how do we get that kind of data into HDFS? And that's where Flume comes into being. Flume is one of those mechanisms. It's an ingestion mechanism to get log data or semi-structured or unstructured data into Hadoop systems. And it has this called as log collector. It's not the only one. There are several other applications and systems which do similar kind of capabilities, like Kafka and Spark has some of it, and Storm and several other ones which are there. This is a representative for this box of capability to be able to get data, unstructured data into HDFS. So these two in layers help us really get data from other systems into Hadoop. And this process is called as ingestion. If you have worked in the data warehousing world, you may have heard about ETL, which is extract, transform, and load. This ingestion in the big data terminology is very similar to that ETL process, but it's called as ingestion. And these are few of the mechanisms which help us to do that ingestion and get the data into HDFS. Let's go to the central blocks over here. MapReduce primarily has been written in Java. Not everybody likes Java or knows Java. It's a lower level machine language, and I think there is a lot goes behind it. People who know Java and love Java, they love Java, but there is not for everybody. And that's why there are several other languages which were created, which are called as high level language. One such language was called as Hive, which was created by Facebook and then open source to the community. What Hive is by far the most popular in this whole ecosystem. Why? Because it uses SQL kind of query mechanism. And most of the IT community, whether it is business users, it's a data analyst, you know how to interact with SQL. And that's why it's the more popular component in the whole ecosystem. We have a language. So what happens when you write a SQL in Hive, which is select star from certain table, it really goes behind and runs automatically a MapReduce job. So the program and the API is written in such a way that you are encapsulated out of it, and you can just write simple SQL, but behind automatically takes care and writes those complex MapReduce jobs for you. So that's the beauty of Hive. So it's a high-level language. Similarly, there is another one which is called Pig. It's by Yahoo. And it's another high-level language. It's not like SQL, but it's very much English kind of languages. It's used a language called Pig Latin, it has lots of English words. It's a data flow language. You like step by step. If I want to filter the data set, I write filter. If I want to write group by, I group it, all so and so forth. It has its own language. It's very much English kind of a language. Also a high-level language. So in that way, it's similar to Hive. If you write Pig scripts and Pig commands, it automatically behind scene writes MapReduce jobs for you. And you don't have to worry about that. So that's the beauty of these two languages, Hive and Pig. Pig was written by Yahoo and given it to the open source world. So people question, why do we have to? It's the revolution and the evolution happening in the big data or this technological space, different companies coming with different approach and thinking their approach and coming up with interesting solutions. Most of the companies I've seen is use Hive for sure. There are certain implementations use Pig, and certain have used combination of both them together as well. Central two boxes. Mahout is an open source mechanism to do machine learning. And machine learning has been a buzzword around, and there is a lot of traction happened around later part of 2015, and many companies, whether it is Google came out with its own machine learning algorithm, Amazon gave out its own other machine learning algorithm, and several companies have come forward to do that. Mahout is one of the open source ones, and the prior one, which has been used by data scientists and several other roles in this community to really create machine learning capabilities on top of Hadoop and this kind of data. This also could be considered as a tool for the data scientists, Mahout and R. R connectors. R is a language which was written and been used by data scientists for years and years. It's a statistical language. A lot of mathematical problems and solutions in statistics can be do that. So this R connector allows the capability to really connect it to the big data and allow that processing for that. So those two are really tools which the big data data scientists would be using to process Hadoop data and even sometimes other set of data as well. These have been there for quite some time. R has been for decades in the industry. On this side, HBase, and this way I think maybe we are talking about CAP theorem and everything. So HBase is a representative set again. Here is an example of a NoSQL database. There are many of them. Actually, there are hundreds of which have mushroomed these days. And it's all the principle of whether relational versus NoSQL databases. And it could be a deeper topic, but at a high level, what they do is really provide a capability to have data setting in a columnar fashion or in a key value fashion or into document databases. So it stores data not like a relational database in the raw format, but in a different kinds of formats. HBase happens to be the open source category, open source candidate in this. There are other ones like Cassandra, MongoDB, DynamoDB, and so on and so forth, and many keep on coming every other month for that matter. The unique thing about HBase, it sits on top of HDFS. So the slide is literally showing it sitting on top of HDFS. So it uses the data on HDFS. So it's very much dependent on HDFS. It's an open sourced version, one of the open source. Many of the other ones are not open source. So that's advantage of it. But there are many of them, and they serve a certain purpose. So each of them serve a certain purpose and use case, and I think we'll be later having some point of time a meetup or a discussion primarily for HBase or NoSQL category as well in future. The three leftover boxes, the Zookeeper, Oozie, and Ambari, these are tools which an administrator in the whole project or the corporation would be using to administrate the whole the cluster. Ambari would be a mechanism for somebody to add more nodes. The point is just saying you can start with a 10 node cluster and tomorrow you can go up to 50. So this is the place. Ambari is one of those options where you can really expand your node, remove some nodes and all that, as well as monitor and provision the processing. Is a coordination engine which really helps us coordinate all these different components. It's almost like a zoo which we have created with pig, we have elephant and all that. So definitely we need a Zookeeper, and that's what the Zookeeper symbol and this icon is doing. Is a scheduling mechanism. So if you write your jobs, all the scripts and programs, whether it is MapReduce, Hive, Pig, and so on and so forth, you want them to be scheduled on a certain fashion on a nightly basis or a periodic fashion. And that's where Oozie comes into capability. It provides you a mechanism to write them in a structured way, whether it is one chained after other or dependencies, and all that great functionality can be brought. So those are three primarily used by the data admin to really manage the whole ecosystem. So those are three components which we'll be doing. So this briefly talks about the ecosystem. I know that could be a lot to cover in a very few short period of time, but this helps you at least get familiarized with what are these terms and what they are used at a high level, please. So here is an interesting slide and a picture which I want to present why I'm showing all these candies. The reason I'm showing all these candies is because I want to talk about all these different companies which have provided big data solutions. First and foremost, we have to understand that all of this is open source and part of Apache Foundation, which is the mother of all. So that's the primary sugar behind all this candy, if you would think. All these other companies, they are called as flavors or distributions. They're literally, that's a technical word. You can go to a company and ask which flavor of Hadoop you're using, and they might answer one of these names to you. Or they are called distributors. Their reason called the distributors because they're distributing the software. They're not creating the software. The software is already provided by Apache. What they are doing, they're distributing it to you and maybe adding some kind of flavor or a change or version. Each company has provided some unique things to be competitive, but there are several of them which have come after the event of Cloudera, as I talked about. There is Hortonworks, which has a lot of the initial members of who created Hadoop. MapR is another one. Amazon and Microsoft and several other companies want to be in this revolution, and this list keeps on growing and growing. So I just wanted to throw out what this means in the whole ecosystem. Understand they are more or less 70 to 80% similar because, as I said, everything is the mother of all is Apache's Hadoop. All of these are variations of it. So if you understand or know one of them, chances are that you know a lot of the other ones as well. So do not be restricted too much in thinking like I understand cloud data doesn't mean that I don't understand Part2 works. For most of the time, you won't even feel the difference for large part of it. But yes, there are uniqueness each of them has brought to the table. What kind of services they provide? So there are three kinds of primary services these companies provide. Their bread and butter is on support. So the whole birth of these companies came in because open source softwares like Hadoop and all of this one were not supported, and the enterprises really needed to have supportability. Otherwise, they could not take this into a production environment. So that's their main revenue model. What they also do something called as packaging. Packaging, we talked about this whole ecosystem a few minutes back about Hive and Pig and so on and so forth. It could be quite to keep up with this different components, and each of them keeps coming with a new version and changes. How does somebody know that Hive version so and so is compatible with Pig version so and so? All that has to be ensured, and these companies are really providing that capability for businesses. So businesses can continue doing what they are focused on and not be stuck with this continuous flow of technology and provide this packaging services. Obviously, they provide training because of all their expertise and knowledge into this area. They provide trainings as well. So these are three things which primarily, I think, at a broad level, which these companies do. On to what we were talking about, Hadoop ecosystem, and let's talk about how this Spark has come to this whole revolution and how it has changed. I think this has become a hot topic in the industry about Hadoop to Spark face-off. So let's do a very quick, brief face-off between Hadoop and Spark. Honestly, the face-off would not be with Hadoop, it would be with MapReduce. So what I was talking about, Hadoop has two parts, part and the processing part. Spark is only providing the processing capability. Spark providing that kind of only processing capability is actually only competing with MapReduce. HDFS still remains, all those things still remain in being and existence. So let's do a quick face-off and the comparison between these two. So we saw this ecosystem and we saw how all of these together are providing capability to have the real interesting use cases for businesses. All this was great and interesting happening and so much revolution, but it's a lot of challenge in terms of technology to keep up with all of these moving components. Into being, it approached this whole ecosystem in a very different way. First, as I mentioned, it is primarily focused on the processing side only, so compare that. Instead of MapReduce, Spark has its core engine. It has its internal core engine. It's not replacing Yarn. Somebody can get confused with that. It's not replacing Yarn, but it's replacing the MapReduce part of it. Has come out into webinars and sessions saying that Spark will replace MapReduce. What does that mean? And trying to do implementation of big data should look into Spark as a processing engine and not MapReduce. For companies who are already using it, they will be using it for quite some time. It could be months and years and before companies transition, and they may have already things in their implementation. But Spark is the future direction, and a lot of more work is happening in the Spark space. The approach which Spark has taken, it has this core engine, and then it has built something called as library. It's a library called Spark SQL, which is very similar to Hive, which allows a kind of capability on top of Spark. Having a different language, a different system, it has been plugged in as a library in part of Spark. Hive and Spark SQL, I'm not going to say that it's completely replacing 100%, but it's a similar representation which I want to try to highlight. Something called as Spark R. So it could be equivalent to what the R connectors were being providing to us before. Also has an mlib library, machine learning library, which could be equivalent to Mahout, and that's machine learning capability. Spark has a Spark streaming library, which helps us to ingest the data to some degree. It's not a pure replacement of Flume. I have to be very cautious out there. What it is doing a real-time processing. So it's getting the data at a real time and processing it right there and there. So the example is something which I want to find a particular solution. I'm getting it while the data is coming into my system itself. So it provides that ingestion, but also provides real-time processing capabilities. The Spark also has, and the library set keeps on growing and growing. It has a library for graphics, which provides the capability for social graphs, which lots of companies like Facebooks and LinkedIn's of the world would be using quite a lot. Not necessarily Spark graphics, but this graph capability. So Spark provides its library to tackle that kind of a graph capability problem. It has in alpha mode right now called as a BlinkDB, which is another library which is built, and it's a very interesting mix about on SQL. And what it does, it is an interesting set which says, I'm going to run a query, and big data queries could take quite some time, sometimes hours and days as well, but I'm time boxing it. In a way, I'm saying, I want my result in next 30 minutes. And I know the result may be not perfect, but give me the result. And give me the probability how much a percentage if it's right. It's fine to, if I can go with that. That kind of capability Spark is bringing through BlinkDB. So the point here is what Spark has taken an approach, instead of having these different components, it has brought something of a unification to this whole ecosystem. And believe me, this is a blessing to the industry, and that's why everybody's excited, whether it is the developer community, whether it is businesses, because everybody wants to be using these applications and seeing interesting use cases and not only just keep up with this technology. And that's why Spark is very much a right step in this direction to unification of this big data, and it's bringing some kind of sanity to this whole ecosystem. When I visually do this thing, I think it's really remarkable to see how it's changing the landscape, and this visual diagram shows that it's captured a lot of things which the Hadoop ecosystem was doing it through various different components. What's left is actually the storage piece, which, as I mentioned, Spark has no interest in going in there. The HDFS, which is the storage mechanisms, this is a database, whether it is NoSQL database or columnar, but it's a database, so Spark has no intent in that. Spark can sit on top of this data and do the processing and do all these interesting, fun things on top of it. Pig, for that matter, is very similar to Spark. There's a joke around like Pig was developed by a drunk set of programmers, and it is a sloppy language and it has great features, but Spark seems like the next version of Pig, but in a very glorified and a very elegant way. So a lot of the principles which Pig does are also part of Spark. So you could, in certain ways you can call it Pig version 2 is Spark, but with a very, very powerful feature set and a library set. So that's how this ecosystem is built. And this administrative tools, again, these three which I talked about, is not something which Spark is interested. So that's not its core area. This is something which the developer administrator will be using to administer the cluster. So that's a quick face-off or comparison what Spark is doing and what few direction tips which somebody should be doing. Few other points, Spark opens up the world also across for different people. Spark is not only written for Java people, as MapReduce was. It was very limiting, and that's why you had all these high-level languages like Hive and Pig and several other ones, which Spark is actually written in Scala, and it allows you to code in Java or Scala or Python. So all of these capabilities open up for different set of skill set people and much better engine on top of it. Talking about Spark has taken as a library-based approach. It has its core in the center and all these different libraries, whether Spark SQL and machine learning, and you're getting the real-time data to streaming, all that can happen together. And that's why this is the beauty of Spark. And they can all function together. You could be getting a real-time data fed into it system, and you can be doing to a machine learning on top of that and resulting that data into some Spark SQL query. All that can happen together. So this unification is a blessing to the whole ecosystem in my mind and the whole big data industry. we conclude the face-off and this particular module. I'll open up for questions. Please unmute yourself and ask any questions.